All right, so now we're putting this all together to find roots of polynomials. And we should be able to find all of them, imaginary and real. Okay, so we're going to put together all the tools that we've learned to be able to do this. The things that you're going to use a lot are going to be graphing, using your graphing calculator. You also use synthetic division when you can. Sometimes you may have to use long division, but most of the time you probably can get away with synthetic division. And all your strategies to solve quadratics, which would be, graphing, factoring, quadratic formula, completing the square, those types of things. All right. Now, a couple of things I wanted to mention just about factors. When we did synthetic division, if you saw this as the divisor, in the box for that, you put -3. That was because that's the root, right? Okay, so today, when we're going to use graphing, we're going to use synthetic division, but you're going to start by using the graph. Let's say I look at this graph here on the right, and where it crosses the x-axis right here, that is, let's say it's +6, okay? So now, because this is not, 6 is not written in as a binomial, that is actually the root. So here, you're going to put 6. You're used to getting it from a binomial and writing in the root, putting the opposite. But because now from the graph, you already know the root, it's just going to be 6 directly, okay? So kind of keep that in mind. All right, now here is a polynomial, and it's a rather large one, and we are going to find all of the roots, real and imaginary. And we're going to start by taking this polynomial and graphing it on our graphing calculator. That's really what you want to get started, and that will help you find some of the real roots, hopefully. Okay, so let's do that. Let's go to our graphing calculator. We're going to go to the y equals screen. We're going to type in that big polynomial here, x to the 4th minus 3x to the 3rd plus 5x squared minus 27x minus 36. Okay, now I can't see the whole thing, but usually 4th degree, kind of have the W shape. I can't really see the bottom of that. But it does look like, if I zoom in here a little bit, it looks like, oops, sorry about that. Let's try that again. Okay, it looks like I have a root of -1 and maybe 4. Okay, so those look like 2 real roots potentially. I want to go to my table to confirm that they're actually 0. So I'll go second table, and let's see, -1. I have to go up here. Here's -1. Yep, it's a root. So that confirms that, and so is 4 because y is 0, right? So that's important. Okay, so now I've got that. My graph looks like this. I know 2 of the roots, but how many roots are total? Well, it's a 4th degree polynomial. So that means so far I know 2 of my roots. One is x equals -1, and another is x equals 4. Okay, we found those from the graph, right? We got our graph and got those 2. But now that means we have 2 missing ones, and they're imaginary. So how do I find those? Well, what you're going to do is you're going to use synthetic division to get this down to a quadratic. It's a 4th degree. When you do synthetic division, you reduce it by 1 degree. Well, luckily I have 2 of these, so I can get it down to a quadratic. And then once I have a quadratic, I have lots of strategies. So it doesn't matter which one I'm going to start with, but I'm going to take one of my roots. Now when you plug this in, it's going to be the root exactly. So -1 is a root. That goes there. And now I'm going to make sure I don't have any missing terms and write my coefficients. So 1, -3, 5, -27, and -36. Okay? All right. Now, bring down your 1 and then kind of go. Take your time, be careful. Now when you do this, because it's a root, remember you should have a remainder of 0. If you don't, something's wrong. Okay, so now I have that. Now this represents a polynomial, but I want to keep going because I've got another root. I got 4 here. So I'm going to take this and I'm going to do this again. Okay, but now I'm going to use 1, -4, 9, and -36. And in this box, we're going to put 4. Okay, so 1's going to come down. So I have 1. I got 4 times 1, 4, 0. That's 0. That's 9, 36. And that's 0. Okay, so again, I got a remainder of 0. Good. Now, what does this mean? Well, remember, I want to write this. What is this polynomial? So this, I reduced it to a third degree. And now I'm down to a second degree, or a quadratic. So this is x squared plus 0x plus 9. Okay, so that is that function. Okay, now I need to solve this to figure out what my other roots are. Okay, so far we're part of the way there. I'm going to get rid of this now. Okay, and I think I'm going to take this, move it up here. All right. Now, I want to know, when does this equal 0? So now what I'm going to do is I'm going to set this equal to 0, and I'm going to solve. Now, you could use quadratic formula, but notice there's no bx term here, and when I have that, the easiest way is to solve with square roots. So then it's easy just to move the 9 to the other side, right? Subtract 9 from both sides. I get x squared, right? I'm just doing this. Sorry, I skipped that step. But that's what we just did. And now I can take the square root of both sides. Square root here, square root here. So this would give me x equals plus or minus 3i. Now remember, it should be i's, so that makes sense. So my other two roots are 3i and -3i. So I want to write all my roots here. Okay, I think I'm going to get rid of this. Maybe I'll do this too. Okay, so my roots are, these were my first two. Now my other two are 3i and -3i. Make sure you list all of the roots. You should know how many you have. I've got 4, 2 real ones and 2 imaginary. Okay? And that's how you solve a polynomial. That's one of the things you can do. Okay, now let's try another one. Okay, here's another quartic function. And I'm going to start again by graphing and see what I get. Okay, so y equals. So this one is x to the 4th plus 7x to the 3rd minus x minus 7. Okay, I can kind of see a little bit of that w. If I zoom in a little bit here, it looks like I'm at 1 and -2, -4, maybe -7. Okay, so those might be my 2 real ones. I want to look at my table. 1 for sure is 0. Now I want to go up here to -7. Yep, y is 0. So -7 and 1 indeed are my roots. Okay, so now I know a couple roots. I'm just going to write those. X equals -7, x equals 1. Okay, so now we're going to use our skills here. I'm going to start with -7. Now this one you have to be careful. There's no x squared term, so I'm going to need a placeholder. I've got 1, 7, 0, -1, and -7. Okay, bring my 1 down. Okay, so what do I end up with? This is kind of weird. That's a 3rd degree, so now I'm just going to take this. And yeah, it's kind of weird. So I got 1. Well, let's use a different color. 1, 0, 0, -1. Now I'm going to use +1, my other root, right? Okay. 1, 1, 1, 1, 1, and 1. Oops. This is my... Okay. Well, how about that? So this, what does this represent? It represents x squared plus x plus 1. Okay. Well, could I factor it? Are there two numbers that multiply to be 1 but also add up to be 1? No. Well, I know they're imaginary, so I probably can't use factoring. So maybe here I decide I'm going to use quadratic formula to just be sure, because the quadratic formula is safe. So I'm going to maybe get rid of this. And let's take this and do the quadratic formula. Okay. So set it equal to 0 now, and I'm going to solve this. So let's see. X equals opposite of b plus or minus the square root of 1 squared minus 4 times a, which is 1, times c, which is also 1, all over 2 times 1. Okay. Okay. Now, if I do this, I have 1 squared minus 4. That's going to give me 1 minus 4 is -3. Okay, simplify this. I get -1 plus or minus I root 3 over 2. Now remember, I want to look at this coefficient, and this coefficient, and see if I can reduce if they have anything in common. They don't, so this would be my other two roots. So I'm going to write those out. One of them would be x equals -1 plus I root 3 over 2. And the other one would be -1 minus I root 3 over 2. So these are my 4 roots. And again, 2 of them are imaginary, so that makes sense. So once you get it down to a quadratic, you really have to determine what's going to be the best way to solve them. It might be square roots, it might be quadratic formula, whatever you're comfortable with. Okay, and that is how you find roots of polynomials. Now, if it's a 3rd degree one, you only have to get it down to a quadratic. You might only have to do this once. It really depends on which kind of function you're dealing with. Okay? All right. Do your assignment. That should say finding roots of polynomials, and write it into your planner, and then check it off when you get it done. All right. Hope that makes sense. Bye.